You can get out your notes. We're going to finish 3-3. Or I'm sorry, 3-4. This is 3-4. Okay. And we're going to do our graphing today. So these are the guidelines to go through these graphs. So you should be writing these guidelines down. The first thing we'll do is find the end behavior, if we can. And then the y-intercept, then the zeros. And I'll use all of that and the multiplicities to sketch a smooth, continuous curve. So when it says graph using the guidelines, it's these 4 guidelines here that we're talking about. So really it's the first 3, and then the 4 is basically the graph. Okay, so when it's in factored form like this example, then the zeros are easy to find, but maybe the degree, the end behavior might be a little bit harder. So I'm going to go ahead and list out 1, 2, 3 here. And I'm going to start with number 3 with the zeros because that's what's easy to find. Okay, so if my factor is x plus 2, the 0 is -2. And if my factor is x minus 4, the 0 is, and x minus 1, the 0 is 1. Okay. So then I can make that little chart because I want to use multiplicities to help me graph as well. This one, all the multiplicities are 1, so you might not need the chart. But this chart will also help us find our degree, which we need the degree to know the end behavior. Okay, all the multiplicities are 1. And we find the degree by adding the multiplicities. So that's 3, and that's the degree. Okay, so if the degree is 3, that means the degree is even or odd. Odd. So my tails are in opposite directions. Okay, and the leading coefficient, so there's nothing here out front, so that's just a 1. So it's positive. Okay, so then just informally, what's our end behavior? Yes, down, up. So if the question is specifically asking you about end behavior, like that's the only thing you're finding, like you did on the warm-up, you will want to write it formally as x goes to -infinity, f of x goes to blank. And then as x goes to positive infinity, f of x goes to blank. But just to help us graph, we don't need to do that. Okay, just informal, down, up. Okay. So also then here on 2, that's the y-intercept. So you find the y-intercept by plugging in 0. And when it's in factored form, you actually have to calculate that. You have to type it in your calculator, or I mean, you can do it in your head as well if you can. So I believe I get 8. So that's 0, 8 is my y-intercept. So that means I'm going to set my scale here 10 and 10. 0, 8 is my y-intercept. My zeros are my x-intercepts, so -2, 4, and 1. Okay, these are multiplicities are all 1. So for their action at those zeros, what's that going to be for all 3 of these? Yeah, just straight through. So I mean the same thing there. Straight through, straight through. Okay. Another thing I'm going to talk about finding is where those turning points are, because I can make a more accurate graph. And I can find that those turning points by using the mid-interval. So finding like the midpoint of the 0 and plugging that number in. So, and you won't have to do this every time. This is more of an extension. But if it asks you to find them, and it's also kind of nice to know, it just gives you a little bit better graph. All right, so we want to use our mid-interval. So here's my 3 zeros. So, and I know I go through, and then I'm going to have a turning point somewhere between -1 and or -2 and +1 because I go through here too. So in between here, that's going to be at the mid-interval. So between -2 and 1, so I count 1, 2, 3 units. Okay, so halfway would be right here at -1.5, or I'm sorry, -0.5. So -0.5. Okay, so I'm going to plug that in for x and find out where that would be on my graph. So 0.5 plus 2 times 0.5 minus 4 times 0.5 minus 1. So we calculate that, and that 10.125, that was, no. See if I remember. No? What is it?
I got 4.
Okay.
I got 3.5. I could have put that in.
All right. So I'm going to plug it in.
Okay, I put that in. Redo. I didn't get that, but
Yes. Yes. It should be -0.5. That could be our problem. Thank you. Thank you. Do we get 10.125 now? Okay. Okay. So yeah, sorry, that was my fault. -0.5, 10.125. Okay, so that's where I'm going to turn back around. So that's right about right here, right over 10. This y-intercept is still a point, so I'm going to go back through that point, and then I'm going to turn around somewhere down here. So now I want to find the mid-interval point between these two. So that's 1 and 4. Okay, so where is the middle there then? 2.5. So plug in 2.5 now. And that should give us negative 10.125. Okay. So that turning point is here. Okay. Okay. And now that's a pretty good representation. We should be able to draw a nice graph now. Okay, so I'm going to start down here. Then I turn here. I also go through that y-intercept. Questions about that? What about any questions about the turning points? So halfway between your zeros, that's what you'll plug in for x. You only have to do it if it specifically asks you for them. They're not technically really a part of these guidelines. Okay? All right, let's do another one. So since this one is in factored form, I'm going to start with number 3, finding my zeros. Okay, so I have, what are my zeros here? Negative 3, negative 1, and positive 2. Okay? Negative 3, negative 1, and 2. What's the multiplicity of negative 3? 1. What's the multiplicity of negative 1? And negative 2, or and positive 2, I mean? 2. Right? So that tells me that my degree is 5. Okay, so the degree is odd. You have a number out front of your vectors? No. So leading coefficient is 1, which is positive. So odd degree, positive leading coefficient, my end behavior is down, up. Okay? Find the y-intercept. we should get 12. So you got you. All right. Let's talk about these actions from the multiplicity. So at -3, multiplicity of 1, I go straight through. And at -1, I bounce, and at 2, I okay. I'm going to ones on the x, but I'm going to do 2's on the y, count by 2's. All right, so my y-intercept is 0, 12. Okay. -3, -1, and 2. Okay. So I'm going to erase this, but let's think about our turning points. So I'm starting down here, and at -3, I go through. Okay. And then I know I have to get here, but first I have to come back down to -1, where I bounce. And then I know I got to go through here, and I got to come back down to 2 again, where I bounce. Okay, so that means I have 2 turning points here and here. So halfway between those zeros. So if we just calculate those real quickly, just so we get a good idea. So halfway between -1 and -3 would be -2. So you plug in -2, and I believe we get 16. Okay, so that's -2, 16. And then I have between -1 and 2, so halfway between that would be 0.5. That would be 1/2. Plug that in, and we get a decimal. It's 17 point something, 17.7. I think it's 17 point. Okay, so then I can graph those. So -2, 16, so 12 here, and 0.5, so here's 16, a little bit more than 17. Well, between 17 and 18, really. Okay. All right. So we start down here. I go up to this point, turn around. I bounce here. So I go up here and turn around. And I bounce. This point is there we go. So this time, this one is not in factored form, so finding the zeros take a little bit more time. But it's in standard form, which I can look at and tell what my degree is and leading coefficient, so I can tell the end behavior right away. So what's the end behavior for this one going to be? Yep. Again, down, up. Okay. Second thing is the y-intercept. So when it's in standard form, it's just our constant at the end. So my y-intercept is 0, 12. And then I need to find the zeros. So it does not factor because this is not a quadratic and it's not quadratic form. So I have to do the p's over q's. Luckily, my p is 12 and q is just 1, so I'm only really concerned about the p's, the factors of p's. So 1 and 12, 2 and 6, 3 and 4. Okay, so let's start synthetic division with 1. Keep in mind when you do the synthetic division that you skipped x squared, so it should go 1, 0, negative 13, and 12. Okay. Give you a minute.
This is Cecil.
Yes?
Would you send Nathan Mackey to student administration, please?
Yes?
Thank you.
Does 1 work? Yes. Okay. And do I have a quadratic? Yeah, so once you have a quadratic, we can factor or use quadratic formula. There are some that do not factor, but that does not mean you're done. You have to solve for x, so you have to use quadratic formula. Luckily, this one does. So adds, or multiplies being negative 12, add 3, positive 1, positive 4, and negative 3. So I should have 3 zeros because it's x cubed. So 1, negative 4, positive 3. What about multiplicities? Do any of these have a multiplicity? No. Well, for one thing I know because it's x cubed and I can only have 3 zeros, so I can't have a multiplicity anywhere. And if there were, you would see it. It would come out again. So like if 1 had a multiplicity, then you would see 1 down here. Okay? Okay. So let's graph what we have. I think I will still count by 2's on the y. Okay, down, up. All of these have a multiplicity of just 1, so I go straight through all of those. Negative 4, and and 3. Okay, so just to help us with our accurate graph, my turning point, this is 1, 2, 3, 4, 5. So I got to go over 2.5. That's negative 1.5.
Are we gonna put turning points on the test?
Not on the end class. It will specifically ask you for the information it needs. It's not going to say use the guidelines, like you don't have to memorize the guidelines. It'll say find the end behavior, find the y-intercept, find the multiplicities. Like it'll tell you exactly what it wants. Okay, so someone help me out here. You can just round to one decimal place. So.
Not right.
So I know that it's got to be up here somewhere because I'm going through and I got it across here, so it's going to be over 12.
Yeah. Over 12? I got 2 under 12. I got
Okay.
30.
Okay. So you guys need to work on your calculator skills. I got negative 10. Woo! Because this should be negative. So I need to work on copying down right. Yeah, 28.125. So again, I knew my first answer had to be wrong, negative 10, because that was my end behavior. I know I start here, I have to go through here, and go through here. So I can't somehow get back down here without, again, crossing the x-axis in between those two. So I knew that was wrong. I had copied that down wrong. Okay, so negative 1.5, and then it was 28 something, so somewhere up here. Okay, and then what's halfway between 1 and 3? 2. So is it negative 6? Okay. Okay. All right, now we can draw that. So, wow, sorry, that was very ugly. So if you get something that looks this bad when you're graphing on your test, take the time to redo it. Okay. All right. So if you got the negative 10 or whatever here when I had made that mistake, then your calculator skills are fine. But if you didn't, then if you didn't get the negative 10 or whatever, or this 28, then something's wrong and you should probably practice. doing this a few times, making sure you're using parentheses right. Okay? Okay, so questions about that? All right, we are going to now go backwards, write the polynomial from the graph. Okay. So first of all, let's talk about our degree. So how many total turning points do you have? Three, right? 1, 2, 3. So the degree has to be at least what? 4. Has to be at least 4. Okay. So it also, both ends are up, so they're in the same direction. So it needs to be even or odd. Okay, even. And then A, they're both up, so leading coefficient needs to be positive. Okay. So then, now let's do our zeros. So I have how many zeros? 3 different ones. So -3, 1, and 4. Okay, but my degree has to be at least 4. So I need at least how many zeros? 4. So I've got to find another one. So I can do that just with the graph. Because if we, no, I know the answer. Okay. So I know where I can find another one based on the action of multiplicity. So here I go straight through, so that means the multiplicity is 1. Here I bounce 2, so the multiplicity has to be 2. So there has to be 2 1s. And then 4 I go straight through, so the multiplicity is 1. Okay, so this gives me 4 zeros because there's 2 1s. So let's write this in factored form. But I know A is positive, but I don't know that it's 1. So I still have to fill in an A. Okay. So I have to just put A for now. So if my 0 is -3 as a factor, that's x plus 3. And then if my 0 is 1, that's x multiplicity of 2, so squared. And then if my 0 is 4, that's x minus 4. Okay, I need to figure out A. It tells me how to do that. It says check the y-intercept and adjust the leading coefficient. So I could really use any point on the graph. The y-intercept is just the easiest. So that's 0, -1. So any point besides the zeros. So I'm going to plug 0, -1 in for x and y, x and p of x, and solve for A. So that's -1 equals A, 0 plus 3, 0 minus 1 squared, 0 minus 4. What? Okay, so we should get -12 here. Just try to stay as hard as you can. So A is positive 112. Okay? For polynomial form, that's standard form, and you just have to multiply it all out. We won't do that. I will give you what the answer is, but we're not going to take the time to do that. Just a note that when you do it, wait to distribute the 1/12 till the end. So do all of this multiplying first, and then distribute the 1/12. It'll just make things easier to wait, because then you won't have that ugly fraction. So this says see back of book, but this is an even problem, so I will go ahead and just give you that answer. Okay. So we're going to look at a word problem, but it's pretty similar to this. The graph is given to us. So I'll give you some time to read it. This is the same graph as this. It's just made bigger. And then a little bit there. So the first two questions are pretty easy. And then the last one is just writing the equation. Okay. So minimum degree, so you need to look at your turning points. How many turning points do you see? 3. So that means the minimum degree is 4. Okay, so that's part A. Part B wants to know how many months was the water level below normal. So 0 will be our normal. So below 0, I have right here, that's how many months. Okay, and then right here, that's how many months. So how many total months? Okay. Now, at the beginning of this period, the water level is 36 inches above normal. So that's where M is 0, and the inches is up at 36. So we're going to use that to help us find our A. Use this fact to help construct an equation, model, in factored form, and a polynomial form. Again, I'm not going to worry about doing the polynomial form. Let's write it out in factored form. So I'm going to, I know it has to be at least degree 4, so how many zeros do I need? 4. Okay, so I already have 4 zeros. So writing this out shouldn't be too bad. So if my 0 is 1, that's x minus 1. If my 0 is 2, that's x minus 2. All of these go straight through, so the multiplicity is all just 1. And then x minus 4, x minus 6. Okay, this is right, but I'm going to adjust this based on my variables. So I'm going to change my x's to m's, and I'm going to call this L of m for level. So I'm going to rewrite that. find A. So I'm going to use this 0, 36 here. So I'm going to plug 0 in for what? M. And I'm going to plug 36 in for L. And that will give me, help me find A. Okay. So you should get 48. Multiply that out. Divide. A needs to stay a fraction, so that should be 3/4. Okay, plug A back in. So 3/4 n minus 1, n minus 2, minus 4, n minus 6. Multiply those all out to find polynomial form. So again, wait to do the 3/4 to the end. FOIL the first two, FOIL the second two, and then that will be a trinomial times a trinomial, which we've done, and then distribute 3/4. So that's how you multiply that out. Okay, so we're going to stop there.